Hey everybody, we're going to hit the second half of this video, this electron configuration, and now we're going to talk about the different types of electrons and kind of the reason for doing this, okay? So, or at least part of the reason for doing this. So we're going to start with these definitions, okay? I think I made a typo, not a typo, I just left something out. So take a minute and write this down, but before you do, this should say valence electron, or electrons, and this should say kernel or core electrons, okay? And then, so we have three things. We have the valence shell, which is the outermost energy level, and then we have valence electrons, which are the outermost electrons. And then we have the kernel electrons, which is every other electron that we're dealing with. So if we are going to, let me show you what we mean by this, okay? And the easiest thing to do is to get the Bohr model out and show you what is going on with this. So the Bohr model shows electrons orbiting, okay? We don't divide this up so you can see sublevels and stuff like this, okay? But let me show you what the definitions were, right? You paused the video, you looked at the definitions. So the valence shell, okay, I'll do valence shell, but I'll abbreviate that VS. The valence shell is the outermost ring or outermost floor, or the outermost energy level that has electrons on it. So in this case, here's our first and here's our second. So in this case, the valence shell is 2, and we'll talk more about why that's important a little bit later. Okay, and then the next thing that we talked about was valence electrons, and I'll abbreviate that VE, and that's how many electrons are in this shell. So if we look at this, in this case, we just have this one electron. So there's 1. Okay, and then we have core electrons, okay, or kernel, okay. So I'll abbreviate that KE, kernel electrons, and that's all the other electrons. So this one we've accounted for. So if we look here, that's going to be 2 kernel electrons. And so look, if I take these two, the number of electrons, 1 plus 2, this is 3 electrons. And that means that the element that we're dealing with is most likely lithium. Okay? So because it has three electrons in it. 1 valence electron. So let's go back to the beginning of the previous video and show how the Bohr model will demonstrate the ground versus excited state. Okay. So remember, the ground state is when you have electrons that follow the rules. So here we're just dealing with 1 electron, but remember that 1 electron wants to be closest to the nucleus. We have a little nucleus in here, okay? And so we're going to say that this electron is closest to the nucleus. That makes this the ground state, okay? Here we have an excited state because this 1 electron isn't here, but it kind of moved up to here, okay? That's the ground state, or that's the excited state, okay? So we can see ground state, excited state in terms of this, okay? So now let's take a look at some of this electron configuration stuff using Bohr model. And not only that, but now we can do valence shell. Let's do it just for this one over here. Valence shell, valence electrons, kernel electrons. That's not the question, but let's take a look. So the valence shell, look, we have 1, 2, 3. So the outermost shell with electrons in it is this one. Okay, and then in this shell, how many electrons do we have? We have 2, 3, 4, 5. We have 5 electrons. And then how many do we have in the other shells? How many okay, not counting the outermost. So we have 2, 4, 6, 8, 10. So we have 10 valence electrons, or 10 kernel electrons. And so between the 5 and the 10, that gives us 15, and that's going to probably make it phosphorus element number 15. Okay, nonetheless, which one's ground, which one's excited? Okay, so now for ground state, we want to see if it follows the rules. So we're going to look, and we're going to count here. In the first energy level, we can put 2. In the second energy level, we can put, here, let me move this up a little. Okay. In the second energy level, we can, so 2 in the first energy level, the periodic table tells us that. In the second energy level, we can put 2 plus 6 is 8. Okay, so let's see. So we have 2 here, that checks. In the second energy level, we have 2, 4, 6, 8, that checks. And then this seems to be good. So this is definitely a ground state. Okay, so now let's take a look at this one to see if this is ground or excited. Okay, so again, in the first energy level, we have 1, 2, so that checks. In the second energy level, we have 1, 2, 3, 4, 5, 6, 7. We only have 7. Okay, so if we only have 7, we better make sure that there's nothing in the third energy level, but lo and behold, we do. So this electron should be here. So that makes this an excited state electron, or excited state atom. This is what we're trying to say, okay? So the rings give us some good visual information, but it doesn't give us all of it. It doesn't give us sublevels, and it doesn't give us orbitals, okay? So, but we can definitely use some good information from that to determine excited ground state, to determine valence, okay? So, but we can determine valence shell, valence electrons, kernel electrons. All of this is good, right? We can get those things from that, but we need more detail than just the rings, okay? And so that's why we did the hotel, okay? We can get 1s2, 2s2, 2p6, 3s2, 3p3, and we can do this, okay? And that arrangement is then going to give us some idea of the chemistry of the atom. The last thing that I wanted to make a big, aha moment of is the reason why the periodic table is shaped the way it is because of electron configuration, right? And so we have the S block here, okay, and then we come over here to the P block, and then eventually we get into the D block, and that's here. So, like, the periodic table isn't just this funny arrangement of atoms. It's shaped the way it is because of the way the electron configuration makes it shaped. Okay. Okay, so there you have it. The final part of this lesson.